See, good afternoon to one and all. So, in the previous lecture of electrical machine first, in that unit number 5, that is three-phase transformer, we have discussing regarding different types of connections. In that we have covered near about two connection, that is star-star connection and delta-delta connection. So in case of star-star zero connection, also delta-delta zero connection, star-star 6 connection, star-star delta-delta 6 connection. So these four types of connection we have already covered in the previous two lecture. Now today we will discuss about the next one type of connection. So next one possible type of connection is that the star delta connection. Okay, star delta connection. See, in case of star delta connection, so we will discussing star delta 1 and star delta 11. What is the meaning of 1 and 11? That is star delta 1. What is mean by star delta 1? Star delta 11. This is one of the vector group, star delta 1 and star delta 11. काय meaning आहे त्याचं? What is the star? What is mean by star? First one star. What is mean by first one star? Am I audible? No.
Primary winding in star connection.
Okay. So primary winding of the transformer, it is connected in star. Secondary winding of the transformer, it is connected in delta. And the one numeric figure, that is 1 and 11, shows that the phase displacement, or it may be LV winding, it can be displaced by a HV winding by an angle plus 30 degree and minus 30 degree. So that is lagging phase displacement and leading phase displacement. 30 degree angle na lag hote, 30 degree angle na lead hote. So it will be represented by 1 and 11. So we have already discussed the clock convection. According to clock convection, if it can be shown, that is LV winding, it is on one position. So it will be like this. I will draw the diagram for that. That is, in case of clock convection, this is one clock. Minute hand, it is at position 12, and hour hand, it is at position 1. Okay, that means this represented as a LV winding, or we can call it as a secondary winding. This represented as a HV winding or primary winding. So this LV, it can be this one LV, it can be lag behind by HV by an angle 30 degree. So that means it is represented by 1. They 1 na represent केले. Okay. Now see, similarly, the HV winding, it can be LV winding, it can be lag behind by HV winding by an angle 30 degree. So this is the lagging phase displacement, and it can be represented by 1. If it is represented as a 11, जर हे 11 च्या position ला असेल, so if it can be LV winding, it is at 11 position. Here it is 12, here it is 11. So this LV, or we can call it as a secondary winding, it can be leads by HV winding by an angle 30 degree. So it can be represented by 1 and 11. Okay. So this is just a representation YD 1 and YD 11. So primary of the transformer, it is connected in star. Secondary of the transformer, it is connected in delta. Primary star मध्ये कनेक्ट केले, secondary delta मध्ये कनेक्ट केले, आणि त्याच्यामधला जो का phase displacement angle आहे, that is angle between primary and secondary, it is nothing but 30 degree. Primary किंवा HV आणि LV winding मधला जो काय angle आहे, it is nothing but a 30 degree. See, there is a plus 30 degree or minus 30 degree phase shift between secondary phase voltage and the primary phase voltage. Secondary sideचं phase voltage आणि primary sideचं phase voltage जे आहे त्याच्यामध्ये 30 degree phase displacement आहे. whether it is one phase displacement, that means whether it is plus 30 degree or whether it is minus 30 degree. That means minus represented that the lagging phase displacement, plus represent that the leading phase displacement. The connection of star delta 1 is shown in figure. So the following figure, it will be shows that the connection of star delta 1, connection आहे, this connection, it will be nothing but the star delta 1 connection, and the voltage on the primary and secondary side is shown in the phasor diagram. Okay, primary and secondary sideचं जे काय voltage आहे, it can be shown in the phasor diagram. So the phase angle between the phase voltage of HV side and the phase voltage of LV side, it can be minus 30 degree. See, स्टार मध्ये कनेक्शन आहे, पहिली वाइंडिंग स्टार मध्ये कनेक्टेड आहे. वी विल ड्रॉ द डायग्राम फॉर दॅट. सपोज दिस इज द फर्स्ट वन वाइंडिंग ऑफ आर फेज, this is the second one, and this one is the third one winding or tertiary winding of star delta. It is connected in star, so we have connected it into star, that is R phase. This one is the Y phase and this one is the B phase. If we draw the voltage phasor, that is phase voltage VR, VY and VB be the phase voltages of that star connected system. स्टार कनेक्टेड सिस्टीमचे ते काय आहेत, फेज व्होल्टेजेस आहेत. ओके, सो वी विल ड्रॉ द डायग्राम फॉर फेज व्होल्टेजेस. दॅट मीन्स दिस इज द VR voltage, this one is the VB voltage and this one is the VY voltage. Each and every, if there are balanced system is there, each and every are displaced by 120 degree. ते कितीने डिस्प्लेस आहे, 120 डिग्री ने डिस्प्लेस आहे. ओके, now the another one phase, that means phase of the delta connected system, it is lagging behind by primary or it may be star connected system by a 30 degree. 30 degree angle na to काय आहे, lag आहे. Okay, so that means suppose we are drawing like this, 30 degree lagging म्हणजे सेकंडरी साइडचा जो काय VR फेजर असेल डेल्टा मधला, phase voltage VRY. Suppose I am writing here, that is VRY. Similarly, it will lag behind by VR by an angle 30 degree. 30 degree तो काय होतोय, lag होतोय. Similarly, it will also lag. Similarly, it will also lag. हे तिन्ही काय झालेत, lag झाले. If we form a delta, याचा जर मी डेल्टा ड्रॉ केला तर it will be like this. This delta, it will be okay. हे दिसतंय का व्यवस्थित? We will draw after rough this phasor. See, this one is the VR phasor, that is VR voltage when it is connected in star, VY voltage and VB voltage, that is VY and VB voltage. So secondary side voltage in R phase, that is VRY, it is shifted by a 30 degree angle. So 30 degree angle na काय आहे, shifted आहे. Similarly, this is also shifted by 30 degree angle. This is also shifted by 30 degree angle from primary phase. प्रायमरी फेजर पासून तो काय 30 डिग्री अँगल न शिफ्ट होतोय. सो VRY, VYB and VBR. So if you draw the delta, it will be like this. Okay, so this is nothing but this is the delta connection. Okay, this is nothing but this is the delta connection. Okay, so all of you draw this same phasor draw करा हे सगळे. So here ही draw केली तरी चालेल, ही draw केली तरी चालेल. झालं का? हॅलो, झालं?
Yes, sir.
ओके. सो सी, इथं ही पण फेजर ड्रॉ केलेले बघा. सो दिस voltage, this one is the voltage. It is voltage phasor of primary side, which is connected in delta, so which is connected in star, and secondary it can be connected in delta. So the secondary phasor, it will be lags behind by primary. Primary पासून secondary काय होतोय, lag होतोय by an angle 30 degree. 30 degree ने काय आहे तो lag आहे. Okay, so that means it is represented by star delta, whether it is 11 or 1. 1 न रिप्रेझेंट करायला पाहिजे का 11 न? हा, हे मी जे एक्सप्लेनेशन सांगितलं, दॅट इज -30 degree फेज डिस्प्लेसमेंट, whether it is represented by 1 or 11. 1. Okay, that means secondary side phasor or secondary voltage, it will lag behind by primary voltage. Primary voltage ला ते secondary voltage काय होते, lag होते by an angle 30 degree. 30 degree angle ना काय आहे, lagging आहे. Okay, so this is the phasor diagram and connection diagram. इथं connection diagram दिलेलं आहे बघा. So see the 3 winding R phase, Y phase and B phase, which is connected in star. That means second terminal of the each and every winding, it can be connected common, and it is connected to neutral terminal. All three, it is nothing but it is connected to 3 phases. And delta connection, delta आपण असा ड्रॉ करतो. So generally delta connection is nothing but delta. So this one is the delta, or we can write here winding draw. This one is the delta. डेल्टा मध्ये न्यूट्रल पॉइंट अब्सेंट आहे, आणि या टाइप मध्ये जर कनेक्शन करायचं असेल तर ही वाइंडिंग बघा. सपोज हा आर फेज आहे, दिस वन इज द वाय फेज, दिस वन इज द बी फेज, किंवा आर फेज ची वाइंडिंग, वाय फेज ची वाइंडिंग आणि बी फेज ची वाइंडिंग. म्हणजे हे काय झालं, R1 टर्मिनल, R2 टर्मिनल, Y1 टर्मिनल, Y2 टर्मिनल, B1 टर्मिनल, B2 टर्मिनल. सी, सो सी हे डायग्राम कसे किंवा हे कनेक्शन कसं आहे हे तुम्हाला सांगतो मी. सी, दिस इज द आर फेज, वाय फेज अँड बी फेज. याचं R1, R2, Y1, Y2, B1, B2. ओके, बघा R1 आणि B2 हे दोन्ही कनेक्टेड आहे. दॅट मीन्स R1 आणि B2 कनेक्टेड आहे. R1 आणि B2 त्याच्यामधून एक फेज काढलेले आहे. सो दिस फेज इज नथिंग बट, किंवा याचं जे काही कनेक्शन असेल, so this one terminal B2 and R1, it is connected to one R1. Similarly R2 and Y1, where it is R2, sorry, here it is R2, no. These 3 phases, if it is connected in delta, R1, R2, Y1, Y2, B1, B2. As per the delta connection, here it is R1, R2, Y1, Y2, B1, B2. R1 and B2 common hai, that means it is connected like this. This one is the R1, here it is B2. R1, B2, R2, Y1, R2 and Y1, that means this connection it will be like this. And then Y2, B1, Y2, B1, where it is Y2, Y2 and B1. So it is nothing but it is like a star. R1 आणि B2 मधला एक कॉमन जे आहे त्याच्यामधलं R फेज झाली. Y1 आणि R2 मधले एक कॉमन टर्मिनल काढलं, इट इज नथिंग बट Y फेज. B1 आणि Y2 मधले एक कॉमन टर्मिनल, इट इज नथिंग बट B फेज. सो B2 R1 याच्यामधलं एक R1 टर्मिनल, सॉरी R फेज टर्मिनल. Similarly, R2 and Y1, R2 and Y1, where it is R2 and Y1, here it is R2 and Y1. In that, this is one terminal, it is nothing but Y terminal, and B1 and Y2. B1 and Y2, it is nothing but one terminal, that is B terminal. So this connection, it will be like this. See, the 30 degree, that is minus 30 degree phase displacement, secondary phase angle, it will be displaced by an primary by an 30 degree, that is lagging phase displacement angle. So this is the star delta 1. Primary is connected in star, secondary is connected in delta, and the phase displacement between that is nothing but minus 30 degree. Similarly, the phase displacement between that is nothing but plus 30 degree. It can be represented by YD11. Primary is connected in star, secondary is connected in delta, and the phase displacement angle between secondary and primary is nothing but 30 degree, but it is plus 30 degree. Okay, so it can be represented by 11, that is leading phase angle. त्याचा जो काय फेज अँगल आहे तो कसा आहे, लीडिंग आहे. ओके, सो सी, सपोज प्रायमरी इज कनेक्टेड इन स्टार, स्टार मध्ये कनेक्ट केलेलं आहे. इफ आय एम टेकिंग वन फेजर, वी आर बी द रेफरन्स फेजर, अँड आय एम ड्रॉइंग द फेजर, वी आर फेजर, then this one is the VB phasor, and this one is the VY phasor. Okay, similarly, the secondary voltage, that is R phase voltage, it will leads by primary R phase voltage. किती ना 30 degree, that means this voltage it will be comes here, इथे येईल हे voltage. So this voltage is nothing but VRY, V स्मॉल मध्ये रिप्रेझेंट करतो, VRY, that is this one is the voltage, that is VRY. It will leads by VR by an angle 30 degree. Similarly, हे lead होते हैं, VYB is also leading, VYB is also leading. Similarly, VBR is also leading, VBR is also leading. So see, if we draw the delta of that, is a point upon connect केले, it will forms a delta. Okay, it will forms a delta. See here, this is the phasor diagram. This delta, it will be shifted by a plus 30 degree. त्याचा जो काय voltage असेल, secondary voltage, it will be leads by primary voltage by an angle 30 degree. 30 degree angle ना काय होईल, secondary voltage जे आहे ते काय होईल, lead होईल. Okay, so see the connection of star delta 11, it's shown in figure, and the voltage on primary and the secondary side is also shown in the phasor diagram. The phase angle or the difference between the phase voltage of high voltage side and the low voltage side, it is plus 30 degree. Phase displacement किंवा phase angle जो आहे high voltage side आणि low voltage side मधला किती, 30 degree, that is plus 30 degree. Okay, लक्षात आलं connection. We will discuss regarding advantages, disadvantages. All of you getting this? Connection लक्षात आले का? Hello. You all are present, no? I am asking some question. Hello, please give me reply.
Yes, sir.
How much time required? Okay, so star delta connection, that is primary, it can be connected in star, secondary it can be connected in delta, secondary delta मध्ये connected आहे, primary star मध्ये connected आहे, आणि the phase displacement between that is nothing but plus 30 degree and minus 30 degree. So it can be represented by 1 and it can be represented by 11. 1 आणि 11 ना काय केलेलं आपण represent केलेलं आहे. Okay, now there are some of the advantages of these types of connection, some of the disadvantages of these types of connection, and after that we will discuss regarding application. त्याच्यानंतर परत application काय करू आपण discuss करू. See, the primary side is connected in star, hence fewer number of turns is required. प्रायमरी साइड जी आहे ते आपण स्टार मध्ये कनेक्ट करतोय, and you people know that in case of star connection the current flowing through the phase current and line current remains same. Phase voltage and line voltage are different. That means line voltage it is equals to √3 VPH. VL is equals to √3 VPH, or we can say VPH is equals to 1 upon √3 VL. Okay, 1 upon √3 VL. Now, in case of star delta connection, the primary it can be connected in star, secondary it can be connected in delta. Hence, on the primary side, it will require a few number of turns or minimum number of turns. Kami number of turns लागतील. So this makes the connection economical for large high voltage step down power transformer. See, this is one of the MCQ question. This connection is suitable for which types of transformer? Large high voltage transformer, or it may be small high voltage transformer, large high current transformer, large small low current transformer. So these are the some option. So see, these types of connection it is economical for large high voltage step down transformer. Okay, high voltage transformer having a big size and largest high voltage high voltage step down power transformer साठी काय राहील? Economical or suitable राहील. Okay, so power transformer where it is situated? कुठं power transformer situate असतो? कुठं असतो power transformer situate? At the generating station, right? No, and do you know that the voltage it can be transmitted always in the high voltage? So we required a step down transformer, we required a step up transformer to convert the low voltage to high voltage. High voltage पासून low voltage कडे step up करण्यासाठी काय पाहिजे? Transformer पाहिजे. So it is economical for large high voltage step down power transformer. जो पॉवर ट्रान्सफॉर्मर स्टेप डाउन पर्पज साठी यूज करतोय आपण, म्हणजे सपोज वन ऑफ द जनरेटिंग स्टेशन इज देअर, 11 kV जनरेटिंग स्टेशन इज देअर. 11 kV चं कन्वर्जन सपोज I want to do it into 220 kV and I want to do it is into 333 kV, or it may be only 33 kV. Okay, so see 11 kV चं कन्वर्जन मला 220 मध्ये करायचं आहे. somewhat it is transmitted to some line. After transmission I want to distribute this to 33 kV by some of the industry. काही इंडस्ट्रीला मला काय करायचं आहे? एक 33 kV ची लाईन सप्लाय करायची. So that there are one step down transformer is required having a high voltage to low voltage step down. Low voltage is nothing but not a minimum, but it is 33 kV, or it may be 66 kV, or it may be 132 kV as per our requirement. Okay, so this is first one advantages, that is fewer number of turns, and it will make the connection economical for large high voltage step down power transformer. The neutral available on the primary can be earthed to avoid distortion. आता स्टार मध्ये कनेक्शन आहे प्रायमरी साइडचं, so primary it is connected in star, so that there is one neutral point it can be taken. So this neutral point it can be connected to ground. तो ग्राउंडला कनेक्ट केला जाऊ शकतो किंवा करू शकतो आपण. If we connect this terminal to the ground, then we will avoid the distortion. That means if it is connected to ground, then oscillating component of the current or the third harmonic component it will be reduces, or the distortion in the supply voltage it will not happen. Supply voltage मध्ये distortion काय होणार नाही, happen होणार. Now next one advantages is that the neutral point allow both types of load. Okay, due to neutral point on the primary side, it will allow both types of load like single phase or three phase it to be met. त्याच्यावरून three phase load पण आपण देऊ शकतोय, as well as we are able to give the single phase load also. Single phase load is also gives. So this is one of the advantages. Now large unbalanced load can be handled satisfactory. Okay, so if unbalanced concept we have already discussed. So if there is a large unbalancing or it may be large unbalanced load is there, जर त्याच्यामध्ये large unbalanced load असेल, so this large unbalanced load it is also handled satisfactory. त्याचं जे काही हँडलिंग आहे, this is also done by satisfactory. Now the star delta connection has no problem with third harmonic component due to circulating current in a D. It is also more stable to unbalance load since the D practically redistribute any imbalance that occur. Okay, see, in a star delta connection, primary star मध्ये connected आहे, secondary delta मध्ये connected आहे. So it is having a no third harmonic because it is connected, secondary side it is connected in delta, or we can call it as a D. So the third harmonic component, it will not give some problem. That is, there is no problem with third harmonic component due to circulating current in D. D मध्ये किंवा डेल्टा कनेक्टेड मध्ये सर्क्युलेटिंग करंट मुळे जो काही थर्ड हार्मोनिक कंपोनेंट आहे, so there is no effect of that third harmonic component. Also the more stable for unbalanced load. For unbalanced load condition, it is a more stable. It is a more stable for unbalanced load condition. Okay, so see, since the D practically D, that is delta connected transformer, partially redistribute any imbalance that occur. Okay, so हा जो काय डेल्टा कनेक्टेड ट्रान्सफॉर्मर असल्यामुळं जे काही पार्शली डिस्ट्रीब्युशन होईल किंवा इम्बॅलन्स होईल, दॅट इज अनबॅलन्स्ड होईल, ते रिडिस्ट्रीब्यूट केलं जातं. रिडिस्ट्रीब्युशन इज नथिंग बट ते न्यूट्रलाइज केलं जाईल, और इम्बॅलन्स जे अकर होते ते न्यूट्रलाइज केलं जाईल. ओके, so this is nothing but this is the advantages of star delta connection. Now delta connected winding, it will carry the third harmonic current. Delta connected winding, it will carry a third harmonic current due to which potential of neutral point is stabilized. Okay, due to which the potential of a neutral point it is stabilized. So delta connected winding आहे एक, that is secondary winding. Secondary winding, it is connected in delta. So when it is connected in delta, so the delta connected winding, it will carry the third harmonic current, and due to that third harmonic current, the potential of neutral point is stabilized. म्हणजे न्यूट्रल पॉइंट जो स्टार मध्ये आहे त्याचं पोटेन्शियल काय होईल, स्टेबल होईल, दॅट इज स्टॅबिलाइज. Some saving in the cost of insulation it is achieved, okay, on HV side because it is star connected. HV side किंवा प्रायमरी साइड जी स्टार मध्ये कनेक्ट केलेली आहे, so due to the star connection there is some of the saving of copper it will be happen. Okay, त्याच्यामध्ये कॉपर सेव्ह पण होईल, that is saving of copper it will be happen due to the star connection. Due to the star connection, the saving of copper it will be happen. Okay, now but in practice the HV side is normally connected in delta, so that the three phase load like motor and single phase load like a lighting load can be supplied by a LV side using three phase four wire system. Okay, see, generally for both load, that means for both three phase as well as for single phase load, generally the primary winding it is connected in delta. आपण जनरली जर बघितलं आपल्या ऍग्रीकल्चर फील्ड मधला जो काही ट्रान्सफॉर्मर असेल त्याची प्रायमरी साइड डेल्टा मध्ये कनेक्ट केलेली आहे, त्याला तीनच वायर आलेले असतात बघा, अँड द सेकंडरी साइड इज कनेक्टेड टू स्टार, सो थ्री फेज फोर वायर सिस्टम इज देयर. So see, generally HV side it is normally connected in delta, normally delta मध्ये connect केले असेल, so that the 3-phase load like motor load as well as single phase load, that is domestic appliances load like lighting load, it can be supplied on the LV side using a 3-phase 4-wire system. 3-phase 4-wire system चा यूज करून काय करतो आपण, सप्लाय करतो. Okay, now as a grounding transformer in the power system, as a grounding transformer in the power system, that is there is a grounding transformer in the power system. Mostly grounded star delta transformer is used. Mostly grounded star delta transformer it can be used, so for no other purpose than to provide a good ground source in undergrounded delta system. Okay, so स्टार आहे म्हटल्यानंतर त्याला एक न्यूट्रल पॉइंट येतोय, सो फंक्शन ऑफ दिस न्यूट्रल पॉइंट इज टू ग्राउंड दॅट टर्मिनल, किंवा त्याला ग्राउंडिंग किंवा आपण अर्थिंग म्हणतो. सो ग्राउंडिंग इज इम्पॉर्टंट. नो अदर फंक्शन इज देअर इन द पॉवर सिस्टम. मोस्टली ग्राउंडेड स्टार डेल्टा ट्रान्सफॉर्मर इज यूज फॉर no other purpose than to provide a good ground. Only it will provide a good grounding, or it may be good ground source in undergrounded delta system. In undergrounded delta system is used, so it will act as a good grounding point when it is connected in star delta system. Okay, now some of the disadvantages of these types of connection is there. In that first one, in these types of connection, the secondary voltage is not in phase with primary. याच्यामध्ये in phase आहे का? हाँ, whether it is in phase, secondary voltage it is in phase with that of primary or not?
No, sir.
No, there
No,
is a
sir.
some phase displacement or the angle of displacement, that is whether it is plus 30 degree angle of displacement or it may be minus 30 degree angle of displacement. म्हणजे leading तर असेल किंवा lagging तर असेल. What will happen? Hence, not possible to operate this connection in parallel with star star or delta delta connected transformer. Okay, suppose these types of transformer I want to operate in parallel with that of star star and delta delta system. जे काय पॉवर सिस्टीम मध्ये बाकीचे ट्रान्सफॉर्मर आहेत, सो इन केस ऑफ पॉवर सिस्टम इफ देयर आर अनदर वन ट्रान्सफॉर्मर इज देयर, सो सी इन केस ऑफ दैट टाइप ऑफ ट्रान्सफॉर्मर, इन केस ऑफ सच टाइप्स ऑफ ट्रान्सफॉर्मर, सपोज एक ट्रान्सफॉर्मर कनेक्ट केलेला आहे स्टार स्टार मध्ये आहे, दुसरा ट्रान्सफॉर्मर डेल्टा डेल्टा मध्ये आहे, नेक्स्ट वन ट्रान्सफॉर्मर स्टार डेल्टा मध्ये आहे. सपोज आय वॉन्ट टू डू द पॅरलल ऑपरेशन ऑफ दिस 3 ट्रान्सफॉर्मर. मला या 3 ट्रान्सफॉर्मरचं पॅरलल ऑपरेशन करायचंय. सो इट विल बी नॉट पॉसिबल दॅट दिस ट्रान्सफॉर्मर कॅनॉट बी पॅरलल विथ दॅट ऑफ दिस टाइप्स ऑफ ट्रान्सफॉर्मर. या टाइपच्या ट्रान्सफॉर्मर मध्ये ट्रान्सफॉर्मर बरोबर पॅरलल ऑपरेशन करता येणार नाही, बिकॉज the phase displacement between these two types of transformer, it is nothing but whether it is 0 or it may be 180, and the phase displacement between these is nothing but 30, whether it is plus 30 or minus 30. Due to that phase displacement, we are not able to operate these 2 transformer or operate this YD transformer in parallel with that of these 2 type of transformer. या 2 type of transformer च्या parallel मध्ये काय करू शकत नाही आपण, ऑपरेट करू शकत. Okay, now one problem associated with this connection is that it can be associated with this connection is that the secondary voltage is shifted by 30 degree with respect to primary voltage. This can cause problem when paralleling 3-phase transformer, since secondary voltage must be in phase. To be parallel transformer, we must pay attention to this shift. ओके, बघा हेच वरचा पॉइंट जो आहे तोच आहे सेम. दॅट मीन्स देयर इज अ प्लस 30 डिग्री फेज डिस्प्लेसमेंट इन द सेकंडरी साइड और मायनस 30 डिग्री फेज डिस्प्लेसमेंट इन द सेकंडरी साइड. दोन्ही पैकी एक कोणती असेल. इफ आय वॉन्ट टू डू द पॅरलल ऑपरेशन ऑफ द ट्रान्सफॉर्मर विथ अदर ट्रान्सफॉर्मर, अदर म्हणजे सेम असेल त्याच्यासारख्याच कनेक्शनचा तर करू शकतो. इफ द डिफरंट ट्रान्सफॉर्मर लाईक स्टार स्टार कनेक्टेड ट्रान्सफॉर्मर, delta delta connected transformer, So if in case of star star connected transformer and delta delta connected transformer, we want to operate in parallel with that of star delta transformer having an 30-degree phase displacement, then it is not possible. Okay, so it will cause a problem when paralleling. ज्यावेळेस पॅरलल ऑपरेशन परफॉर्म करतोय किंवा ज्यावेळेस आपल्याला पॅरलल ऑपरेट करायचे, म्हणजे बघा का मी सांगतोय, सपोज हा ट्रान्सफॉर्मर एक इन्स्टॉल केला, वायडी ट्रान्सफॉर्मर एखाद्या स्टेप डाऊन साइट मध्ये किंवा डिस्ट्रीब्युशन ट्रान्सफॉर्मर म्हणून कुठेतरी काय केलं आपण, इन्स्टॉल केला. सो हॅव्हिंग अन कॉस्ट इज मोर बिकॉज इट इज अन हाय व्होल्टेज ट्रान्सफॉर्मर. कॉस्ट त्याची भरपूर असेल. सपोज नियर अबाउट कन्सिडर कॉस्ट ऑफ दॅट ट्रान्सफॉर्मर, इट इज नथिंग बट 20 lakh. Okay, now as we know that day by day our India it is having a developing country, so that day by day the demand of electricity it will be increases. Day by day electricity ची demand काय होते, increase होते. Okay, so due to that increased demand we want to increase the power, that means power consumption it is also increases. Due to increased consumption of power, the demand it will be increases, and to meet that demand we want to install the equipment more and more day by day आपल्याला इक्विपमेंटचं इन्स्टॉलेशन काय करावं लागते, इन्क्रीज करावं लागते. सपोज द लोड ऑन दॅट ट्रान्सफॉर्मर इट विल बी इन्क्रीजेस. या ट्रान्सफॉर्मरचा लोड काय झाला, इन्क्रीज झाला, दॅट इज ओव्हरलोड झाला या ट्रान्सफॉर्मरला ओव्हर. सो ऍट दॅट सिच्युएशन आय वॉन्ट टू इन्स्टॉल अनदर वन ट्रान्सफॉर्मर, किंवा त्याच्याच नियर अबाउट अनदर वन स्टार स्टार कनेक्टेड ट्रान्सफॉर्मर प्रेझेंट आहे. So if and load on that star star connection transformer is somewhat less, so some load on that transformer, या ट्रान्सफॉर्मरचा काही लोड मी याच्यावर शेअर करू शकलो असतो when it will be connected in star delta, but because of star star connected I am not able to share that much amount of load. That means we are not operating these two transformer parallelly. हे पॅरलल ऑपरेट करणं गरजेचं होतं, पण तिथं करता येत नाहीये. And it is not possible to replace both the transformer. दोन्ही ट्रान्सफॉर्मर रिप्लेस करणं पण पॉसिबल नाही. What about cost? Whether it is economical? इकॉनॉमिकल होईल का ते? हॅलो. So that means designer should think about future also. डिझायनरनं फ्युचरचा पण थिंक केला पाहिजे. As per the cost requirement, as it is economical, as the load it will be increases, so that while operating parallel it is difficult. Parallel operate करताना ते काय आहे, difficult आहे. Now if the secondary of this transformer should be paralleled with secondary of the other transformer without phase shift, there would be a problem. Okay, see another one advantages. जरी आपण सेकंडरी ऑफ दिस ट्रान्सफॉर्मर, या ट्रान्सफॉर्मरची सेकंडरी इट शुड बी पॅरलल विथ द सेकंडरी ऑफ अनदर ट्रान्सफॉर्मर, अनदर ट्रान्सफॉर्मरच्या सेकंडरीशी पॅरलल केलं, दॅट मीन्स विच आर नॉट इन फेज, दॅट मीन्स विदाउट फेज शिफ्ट, देअर विल बी अ प्रॉब्लेम. दॅट मीन्स अगेन देअर विल बी अ प्रॉब्लेम. सो दीज आर द डिसएडवांटेजेस ऑफ दिस टाइप्स ऑफ कनेक्शन, दॅट इज स्टार डेल्टा connection. Star delta connection चे हे काय आहेत disadvantage. Now the application of these types of transformer where it can be used. So there are some of the application of these types of transformer is that it is commonly employed for a power supply transformer. हा commonly power supply transformer म्हणून यूज होतो. Okay, it is commonly used for power supplying transformer. Okay, now these types of connection is commonly employed at the substation. हे जे काही connection आहे, this connection it can be commonly employed at the substation end of the transmission line. Okay, see these types of connection it is commonly employed at the substation end of the transmission line. Transmission line चं जे काही substation end असेल, at that point of substation end on that transmission line it is commonly used. The main use of this connection is to step down the voltage. या कनेक्शनचा मेन यूज काय आहे, टू स्टेप डाउन द व्होल्टेज. व्होल्टेज स्टेप डाउन करायचं. the neutral available on the primary side is grounded. Primary side ला star मुळे जी काही neutral available आहे, so this can be grounded, and it can be seen that there is a phase difference of 30 degree between primary and secondary line voltage. Delta star connection आहे, sorry star delta connection आहे, there is a phase displacement आहे +30 -30 प्लस किंवा मायनस असेल, that is leading असेल lagging असेल, so it will be also taken into account. It can be seen that there is a phase shift or it may be phase difference of 30 degree between primary and secondary line voltage. Okay, commonly used in a step down transformer. Step down transformer म्हणून commonly use करतोय आपण. Star connection on HV side reduces insulation cost. HV side ला star connection आहे, so that insulation cost it will be reduces. So insulation cost it will be reduces. It will reduces the insulation cost. The neutral point on HV side can be grounded. Neutral point जो आहे HV side ला तो ground करू शकतो. Stable with respect to unbalanced load. If there is an unbalanced load is there, then also it will be stable. हा stable आहे if the unbalanced load is there. Okay, unbalancing it will be occur when there is a non-linear load. It can be connected on the secondary of the transformer. Transformerच्या secondary ला जर non-linear load connected असेल, then there is a voltage fluctuation it will be occur, or it may be unbalanced voltage it will be occur. Okay, so that is unbalancing. For example is given here. As for example, at the end of transmission line, the neutral of the primary winding is earthed. Okay, at the end of transmission line च्या end ला जी काही primary winding ची neutral आहे, this neutral it can be earthed. In this system, the line voltage ratio is 1/3 times of the transformation turns ratio, because it is connected in delta. So in case of delta, VL is equals to VPH, and in case of star, primary star मध्ये connected आहे, VL is equals to √3 VPH. That means VPH it is equals to 1/√3 VL. Okay, so according to the turns ratio, that is VL divided by VPH of the primary divided by VPH of the secondary is equals to VS of the primary, VPH of the secondary divided by VPH of the secondary. याचा जो काही turns ratio असेल, or we can call it as a transformation ratio K, it will be 1/√3 times. 1/√3 times that of turns ratio, and the secondary voltage lag behind by primary voltage. Secondary voltage जे आहे, it will lag behind by primary voltage by a 30 degree angle. ते किती डिग्री अँगल न लॅग होते? 30 degree angle न. So also third harmonic current flows to gives a sinusoidal flux. Okay, third harmonic current it will be flowing and it will gives a sinusoidal flux. So these are the some of the application related to star delta transformer. When it is connected in star delta, having an phase shift of +30 degree, or whether it is phase shift of -30 degree. +30 degree phase shift असेल किंवा -30 degree phase shift असेल. For that phase shift, these types of connection it is suitable for this much of application. Like commonly it is used in the step down transformer. Commonly हा step down transformer साठी काय करतोय आपण? यूज करतो. Okay, getting? Is there any doubt?
No, sir.
Okay, similarly to that much point, star delta, there is another one connection, that is delta star connection. Again delta star 1 and delta star 11. So this point we will discuss in the next lecture, and in this way we will conclude this today's lecture and we will stop here. Thank you.